This is Gunnar Wolf, continuing our PGP alternative or better implementation series. Is that all the name of your talk?
Yep.
Okay, there it is. Anyway, take it away.
Thank you. Well, I'm not going to talk about an alternative, or maybe I would talk about an alternative track of time or something like that. This is, the wrapping up of a project I'm doing as my PhD project. So I'm going to explain what I did for the past almost 4 years, what what am I coming to, and what is the likely future for this. I will try not to repeat what I already said at the first day of the conference. We already heard about transitive trust, the trust distribution models, and that in projects such as ours, it makes sense to focus on the distributed model, which is modeled by the Web of Trust. Now, when we have this model, when user B, in order to know the path of trust for user K, has to traverse several users, it's not only that we need to know whom we trust and whom each other person trusts recursively on the path between one and another key. We need to find the different keys as well. So we are used to having the key server, right? Although, key servers aren't if I just have one key server, it's not particularly a model of decentralization. If I have a centralized key server, it can act as a sensor, it can accept or reject given keys, and that goes against the original design of PGP as a way, to circumvent all those kinds of meddling with communication. So over 20 years ago, there was a work by Jaron Minsky called that implemented a gossip protocol or epidemic protocol, so that if I send a key or I send extra packets to an existing key to a given key server, it will propagate across a network of key servers. In that way, key servers are supposed not to be able to ever censor anything that appears on them. That worked for many years, but slowly we as the wide community found some important attacks that jeopardize the existence of the key server network. Because after all, if the key server network just accepts any kind of packages it receives, it becomes a binary, non-modifiable, non-authenticated, distributed, eventually consistent storage, which means anybody is able to modify it with any kind of garbage. That garbage is impossible to take away. And that, it first became like a playing ground for some not very serious attacks, but then some less well-intentioned attacks started to appear. So my work is focused on something we call certificate poisoning. What is certificate poisoning? Well, I want you all to sign my key because I want to be connected to a wide key ring, and I want to have and to represent the trust that each of you will put in my identity and that I will put in yours, knitting a web together. But what happens if we have an attacker? In cryptography, where we always talk about Alice and Bob, usual name for an attacker would be Mallory. And Mallory can generate tens of thousands, millions of throwaway identities. That is, identities that mean nothing, but can be used for harm. So Mallory generates a very large number of garbage keys that are not related to their original identity, and decides to attack our victim, Vicky. So Mallory adds 10,000 signatures to Vicky's key. What happens next? Whenever you want to communicate with Vicky, you will find it has 10,000 signatures. GPG was known to choke on that. Then they updated something so it no longer chokes, but I mean, who will check 10,000 identities to see which one of those means something? Not only that, Vicky's key will grow very much. I'll go to that in a minute, right? So what happens after this attack that has happened in the wild, has happened in the open a couple of times? What happens is that Vicky must leave her identity, throw away her key, probably revoke it, and start a new identity. Okay, so Vicky comes again to DebConf, gathers signatures from some of us, and what happens? Well, Mallory can attack her again. It will not take too much time for Mallory. So it's an attack we don't have anything against. Well, already explained this when Alice tries to import Vicky's key. So why does this happen? What I characterize is, I found nothing here. I mean, I'm doing this work, and I insisted to my advisor, well, I'm just commenting on other people's ideas. Well, he says that it's valid for the kind of work I'm supposed to do, so I'm happy. The thing is, what happens currently is that when we are asked to take part in a key signing party, all of the meaningful interaction, as you can see here, is done between, say, if Bob wants to sign Alice's key, all meaningful interaction is between Bob and the key server. First, Bob and Alice should identify to each other. Yeah, they should. Of course, I can sign identities for people I didn't really check, but it shouldn't happen. But all of the interaction, all of the real interaction is between these two actors, right? Bob fetches Alice's key from the key server. Bob signs the key. Bob sends the key to the key server. The key server updates. That's it. Alice doesn't control her key at all. And that's the main issue. What I am proposing is to change the protocol by which key signatures are accepted in a key server. Keys will be accepted anyways, but their signatures will have to have something different to involve Alice in the process. So what I'm proposing is that first, Alice and Bob identify each other, as we already said. Then, Bob will search for Alice's key in the key server, gets the key, and certifies Alice's key, but only on his own local store. He generates the certificate for Alice's key, that is the signature, but instead of sending it to the key server, and there's an important issue here, an important thing to note here. This is what we already do with CAF, but CAF is not mandated. CAF is a best practice. Okay? What happens here is that now Bob sends the certificated public key to Alice, and Alice attests this certificated key. What is attestation? Attestation is like a signature on a signature. Is the acceptance of a signature. That's something that not every OpenPGP implementation has. I know Sequoia does. I didn't find it on GNU-PG. It may be, but I didn't find it. So Alice attests the signature made by Bob and sends the attested certification to the server. The server, when the server receives any key together with some certifications, it will verify that any certification received has been really attested. And all of the attested certifications will be added to the information the key server holds and will return to other users. So by doing this, it is a very relatively very simple change. By doing this, we would mitigate, we would counter completely this attack for poisoned certificates. And what I wanted to achieve with this mostly is that this allows us to keep a completely decentralized transitive trust model. We can still have a fully functioning key server network. That's something that we take advantage of as members of a project that's geographically distributed. Of course, my proposal, this is what I showed 2 years ago again at this same conference. I had to come with I had to show that it really helps, that it really is functional. So I set up an experimental network with 5 key servers connected, well, not all to all, but with like a maximum 2-step distance. Of course, those key servers were completely disconnected from the real network. I generated many thousands of keys. I didn't want to pollute everybody's namespace. And I generated 500 key pairs, 500 identities. They sign each other with a probability of 1 of each 100. And between those that are signed, 1 out of 3 is attested. So I chose from the 500 keys, 5 random keys to be attack victims. And the attack victims were signed by 1,000 keys that were not uploaded to the server, that were just created as evildoers, right? So, well, the first thing I tested is that the key server network actually synchronizes. This shows the creation of the 500 keys and the stabilization of their cross signatures, right? One out of each 100 links possible have a cross signature. So in 250 seconds, it becomes stable. And then I made the attack. What is important to the attack? Well, this first part is what we saw in the other graph. But then in this period, we have the attack. And this graph shows that with the key server software as it is, well, the size of those 5 keys that are attacked grows from close to 5 kilobytes to close to 250 kilobytes. Again, it's just 1,000 keys that are attacking. This could be much larger. And well, this is the proof that the attack works, that 5 keys are much larger than all other keys. Then I made, well, one of the things I set up to, and I'll explain a bit more about this, is that I wanted to do a minimal modification to the running software. I did this modification, and with the protocol I am proposing, well, no keys are bloated due to the attack. The keys remain the same size because, of course, the key server will reject any signatures that are not attested. So, I mean, the attack mode, the attack kind that I'm trying to avoid is really avoided. Now, wait, I had some more here. Well, I'll talk about it even if I don't have I don't have the slides for it. There are some caveats to it. This is not like the end all for this problem, because well, while this is possible, first of all, it does require attestations to be part of the toolset. They are currently part of some of our toolset, not of GNU-PG as far as I could find, and I would love attestations to be available throughout, but they are not. So this would not currently be a good way forward, because currently we need to do something that users have the tooling for. Second, this was described to me, I love the term, this could lead to a status of death by kindness. I mean, it works, but we are very few people using OpenPGP. It is a hard thing to understand. It's a hard thing to operate. I hope that new implementations such as Sequoia, such as what we have been talking about in the past few sessions, will help with a more friendly and more flexible way of interaction. But if we added more limitations to what we have to give to a key server, probably fewer people would be able to use it. Fewer people would participate in the key signing and in the web of trust, and that would be bad. Yeah, I think I didn't compile my latest changes, but one thing I was going to mention is that the total number, the total set of changes, I did like, I don't know, less than 100 lines of changes to Sequoia, less than 100 lines of changes to Hockey Puck, and some glue code, so it's quite minimal. I would expect that this can be easily incorporated, but then again, in order for the key servers to adopt this mode of operation, there has to be change. We cannot have some key servers using one protocol, some key servers using the other, because the delta, the difference between them, would grow too much and it will become inoperable after some time. So, I am very happy to reach this point because I am about close to the finishing of this project. I'm very happy to share this with you. And of course, if you have any comments on this, I will be more than happy to answer. So thank you very much.
We have time for one or two questions. We have at least one question.
Thank you, Gunnar, for the exposition. I wonder if you can think of a way to deploy these changes without disrupting the key server network, which on a second thought may not be operative anymore. Last time I checked it just didn't really work. I mean, this HKP network mostly collapsed a couple of years ago. Mm-hmm. I haven't checked since that. So I'm not sure if these worries are really warranted, because we don't have anything practically usable right now.
Well, one thing about academic projects is that I took a snapshot of things as they were 4 years ago, and I have to work on that reality. Many things have changed since then. We have a public alert. Okay, let's all be wary. The key server network was on the brink of collapse. It is no longer the case. It is not as big and as strong of a network as it was, but it is in a much better health. And partly this is because the Hockey Puck software was added with some things, for example, the ability to filter some specific keys. So I know I'm not currently operating a key server. I am about to set up one, but I have followed their lists, and they now and then they say this key should be dropped. Everybody should drop this now. So one of the issues that we had with the key server network before is that people forgot about their key servers for a long time. That shouldn't ever happen. If you run a service, you should be attentive to it. So if we were to propose this change of protocol, we would say, oh, okay, starting from version 2.3 onwards to 2.4 onwards, this will be the new protocol, and everybody must adopt it at the same time. We're doing that on this day, right? A flag day. It is not a very large network. It's a couple of tens of servers. So it's achievable. But again, I cannot assure it would be well received. I cannot assure that this binds with reality in the way we want to keep operating. Yes?
We're going to squeeze in one more question.
Thanks for saving the PGP key servers. One question, did you think about writing a spec for this or something to allow more implementations to support this? Is it something that should go into the core PGP specification?
I would love to. The thing is, I don't know, I have tried to approach the IETF working group, and really I don't know where to grab it from. It's a tough group to join. I mean, I know, and I am friends of several people who are part of it, and it's not that I don't feel confident in participating, but I don't know how to begin. So it could be done, and I think there is place for it there, but I haven't got to it because, well, I've been busy with other things. If you think it is worth it, I'm most interested in following it.
Okay, I think that would be good. Just wanted to understand if there is something that made that impossible, but if you're positive, that's good. Another question, but you're using attestation. Could it be signed sub-packet instead, or why did you choose the attestation approach?
Well, I chose the attestation because it was already implemented. I mean, I was reading through the Sequoia list of options, found that it had an attestation support. It was, in my opinion, back then, still quite incomplete because you could do an attestation, but you could not check it. And the bits I did were to list the attestations present in a certificate. I sent it back, of course. The thing is, of course, I did it against an old version, the version that was valid when I started with this thing. And forward porting it is not immediate. It could be done other ways, probably, yes. But I think if attestations are already part of, well, I guess that what's coming in the new OpenPGP standard, I think having use cases for it would be good.
Looks like that's it. One more time for Gunnar.
Thank you very much.